Have you ever used one of those apps to translate a menu in a foreign country? Or, watched a video with captions that just appear almost instantly? It seriously feels like magic, right? Well, today we're going to pull back the curtain and reveal the secret behind one of the biggest breakthroughs in AI, how machines finally learned to understand our language.
Okay, so let's just dive right in with a little puzzle. Look at this sentence. For you, for me, it's obvious. You know instantly that it refers to the street. The street was too wide. But for a computer, this is a massive, massive challenge. How does it learn the context to figure that out? Well, cracking this exact problem, that's the key to everything. And we're going to see exactly how they did it.
But before we get to that secret sauce, let's first take a second to appreciate just how tough this problem really is. Because as you're about to see, truly understanding language is so much more than just swapping words out of a dictionary.
I mean, just look at this list. You've got slang and idioms like break a leg. You definitely do not want to translate that one literally. Then there's cultural context, where some ideas don't even have a direct word in another language. And what about tone? Is someone being serious or are they being sarcastic? It's incredibly complex for a machine.
And here it is, the single biggest challenge in action: ambiguity. The word bank means two completely different things in these sentences. For years, this is where AI models would just fall flat. They couldn't grasp the context. They desperately needed a way to focus on the relevant words, like deposited money versus river.
So how did they finally teach AI to focus? Well, the answer was a single, absolutely revolutionary concept that changed everything. That secret is a mechanism called attention. The attention mechanism is pretty much the hero of our story today. To put it simply, it gives the AI a way to figure out how important different words are when it's looking at a sentence. It lets the model pay more attention to the words that give the most context. Kind of like how you'd use a highlighter on the most important parts of a textbook.
Okay, so let's get into how this actually works. The whole idea really boils down to three core parts: the query, the key, and the value. And believe it or not, the best way to understand them is with an analogy I think we can all relate to.
All right, picture this. It's Friday night, you're tired, and you're just scrolling through a streaming service. That feeling you have, that desire for something light and funny, that is your query. It's the question, the intent, that you're putting out into the system.
So, think about it like this. Step 1, your mood is the query. The system then takes that query and compares it against all the keys. In this case, all the different movie genres like comedy, drama, sci-fi. When it finds a strong match, like your funny mood matching with comedy, it delivers the value, the actual movie trailer you were hoping to find. And this is exactly what the attention mechanism does with words. It takes one word, the query, and scores how relevant it is to all the other keywords in the sentence. Then, it knows to focus its attention on the most important ones to figure out the real meaning. Of course, the AI isn't actually watching movies. It's all just pure math. What it does is convert every single word into a unique list of numbers, called a vector. You can think of it like a numerical fingerprint for each word. So words with similar meanings will have mathematically similar fingerprints. The AI then calculates these attention scores by comparing the fingerprints to see which words are most related. Okay, so we have our secret ingredient, the attention mechanism. But where does it fit into the bigger picture? Well, it's the powerful engine inside a much larger machine, a revolutionary architecture called the transformer. And that's what we're looking at next. The transformer is actually built on a really clever two-part design. First up, you have the encoder. Its entire job is to read and understand the input sentence, like a sentence in English. It processes all the words at once to build this rich contextual meaning. Then, that meaning gets passed over to the decoder, and its job is to generate the output sentence, say in French.
And attention is the star player in both parts, but in two slightly different ways. Self-attention is when a sentence looks at itself. This is how the encoder solves our original puzzle, figuring out that it refers to the street, not the animal. But then the decoder uses something called cross-attention, where it constantly looks back at that original sentence to make sure the translation stays accurate and doesn't drift off topic.
Now, to make this even more powerful, transformers don't just use one attention mechanism, they use a whole bunch of them at the same time. It's a concept called multi-head attention. You can think of it like having a team of experts all looking at the same sentence. Each head can focus on a different thing.
One head might be analyzing grammar, another one's tracking nouns and verbs, and a third is just focused on the overall tone. It's what gives the AI an incredibly deep and layered understanding of language.
So this is all super fascinating, but here's the kicker. This isn't just some abstract theory. This powerful technology is already woven deep into our daily lives in ways you might not even realize.
So how good is it, really? Well, transformer models have hit over 90% accuracy in language translation, completely changing the game. This is the tech that powers the real-time translation you see in tools like Microsoft Teams. I mean, it's literally turning what used to be science fiction into just a regular Tuesday.
And it's not just about translation. Those suggestions that pop up as you type in a search engine, that's transformers. Grammar tools that fix your writing? Yep, transformers. That cool feature that can summarize a huge article into a few bullet points? You guessed it. Under the hood, they're all powered by this same incredible architecture.
And that's exactly why this is so important to understand. As Professor Hagade points out, this isn't just another algorithm. It's a foundational building block for the future of AI. By getting this, you're grasping a key piece of the technology that is actively shaping our world as we speak.
So there you have it. We went from a simple puzzle about an animal in a street all the way to the complex architecture that powers the AI in your pocket. You now know the secret. It's all about attention, the ability for a machine to focus, to weigh importance, and to truly understand context. So the only question left is, now that AI can understand our language, what will it learn to understand next?